Hey everybody, Mr. Qualls. This is an activity that will prove through a couple of pieces of paper and some drawings and comparisons that the Pythagorean theorem is true and will work for any right triangle. What you're going to need for this project, for this activity, is a pair of scissors, a straight edge, a few pieces of graph paper, and I've got 3 different color pens with me. I usually have a number of those, so go ahead and grab that stuff. I'll be here when you get back. Alright, so now that we've got all the things that we need to be using, we are going to talk about what this means. So what we're going to do is we're going to look at actually physically square A, we square B, and then we square C. It's going to be rather easy to square these 2 sides, or the leg of the problem, or excuse me, the legs of the triangle. But it's going to be a little more difficult to square the edge that is the length of C, or the hypotenuse, because if you look down, this isn't one long, and then there's partial, and then another partial. We can actually count our intersections here and just say, well, that's 5, 6, 7, and get an accurate length, because none of these intervals are the same. These are all the same. We use graph paper is because this is going to be easy over here. But I've got a little thing that I do over here that I think is, if I can say so, I think it's rather brilliant, and it'll just work for us over there. Okay. So realize, or think about, that a squared plus b squared. And what does a squared look like? Well, the length of one side of this triangle, and it's a right triangle. It must be a right triangle. This doesn't work. If I square that side, what I need to do is I need to take this length and multiply by itself and actually physically draw a square out here. This is a as an exponent of 1, and it's one-dimensional. This is a with an exponent of 2, which is two-dimensional, so it actually can be represented as a rectangle, and since it's the same length and width, it is a squared, or a square, and that's why we call this a squared. That's why we squared, just because it's going to make a square down here, and c squared is going to make a square out here. So I'm going to do this one first. Now, we want our idea coming off of this edge from this vertex. I want to take a perpendicular out, and it needs to be the same distance. When I'm in the classroom, and one of the things that we do right off the beginning of the year with this is I have everybody draw me a square. And if you have read anything on my blog, you will percent of the people, even in an advanced pre-algebra room, about 30% of the people will not draw a square. They will draw a rectangle and not pay attention to whether the sides are the same length. And you can look at them across the room, square that side, and they're like, oh, I'll fix it. A square means something. And if you're going to pay attention, if you're going to draw to whether the side lengths are the same, you're not drawing a square. So we have to be very careful here with this. Now, a lot of people start counting 1, 2, 3, 4. That's not what we're talking about. A length is what we're doing. So from here to here is 1, 2, 3, 4, 5, 6, because this side over here is 6 long. So it's 1, 2, 3, 4, 5, 6. Put a dot there, and then over here 1, 2, 3, 4, 5, 6, and mark that one. Now, when I draw lines, you can see how these lines are right on top of the blue lines. A while back I figured out there is a way that people who are a little more careful with their drawings take care of their drawing. And this is what it is. A lot of us will just like, well, I need a line there, so we'll put my ruler up against it, and then we'll put our pen down, and we'll mark the line, we'll pull it away, and our line that's been marked is just off of the line that we really, really wanted. And it's because there is a taper on the end of this pen. So what happens is, if you put your ruler up, and then the pen and the taper don't work together. So the taper, if you hit the taper, the ink is actually going to where you're marking. So if I do this, I'm going to write to the right of the line I want to mark. However, I can reverse this with every do this. And if you do this a few times, you will realize just how clean and how precise your lines are. It looks a lot cleaner. The people when I was younger, they were drawing better pictures than I were. They just knew how to draw better pictures. They didn't and knew the the nuances or the little things that made them clear better drawers, or that they had better penmanship or anything like that. They were when they drew. And that's what I'm going to do right now. I'm going to put my, and I'm going to bring my ruler up to it. Now you can see that the line, I can still see the line. Well, that's because that's where the pen's going to mark. So I'm going to draw my line right there and pull it away. It's right on top of the line. It is perfect. Okay, I'm going to do the same thing here. I'm going to put my first, where I'm going to draw, and then I'm going to, and look at the gap there. I mean, look at the gap between the line. When we do that, the gap between the line and the ruler is incredible. Okay, there it is, right on top of the line. So I'm going to put this pen down first. Then I'm going to put my ruler up here. Make sure that it's right down there. There we go. It's absolutely clean. It's the cleanest I can get, right? So I'm going to do the same thing over here. This length is 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to come down here. 1, 2, 3, 8. Notice how I'm being very careful with what I'm doing, because this is going to be something that needs to be exact. 1, 2, 3, 6, 7, 8. And I know it's going to work because I have a lot of experience with this stuff, and I know that a 8, this is actually going to be a right triangle, and this is going to be a whole number over here as well. And that's why I chose this one, so we don't have to mess with. But you still have to be very, very careful while you go through it. There we go. Put my pen down, bring my straight edge up to the pen. My pen down, bring my straight edge up to the pen. Looks good, right? So, all right. So what we're looking at here is, now we have this thing. This is a squared over here. This is b squared over here. And what we want to do is we want to compare that to c squared. Okay? Now most people, when we're doing this, think, well, I'll just throw that line right like that. I mean, it's got to be right out on those diagonals, right? So you're going to put a mark out here, and if I grab my other mark, my other straight edge here, and go like this, and you can look. Well, it might be difficult to see on the video. They're parallel lines going off, but those are not perpendicular. See, those are not perpendicular. We're going to have this rhombus out to the side instead of parallelogram. It's going to be a rhombus instead of a square. So we need to be careful with that. So what I'm going to do is I'm going to create a measuring device that will actually sit right here, and I can actually come straight off of that thing. And what that measuring device is another piece of graph paper. So I'm going to take another, and I'm going to cut right down one of the blue lines, perfectly down the blue line. So a measuring device, this straight, I have a new straight, and not only is a straight edge, but it's marked with the units. It's marked with the units that I'm actually measuring with. That sounds like a great idea. So what I'm going to write here as 0. And then I'm going to put it right there. And if we look and we come down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 falls right here. So it looks like a 6-8 triangle, a right triangle, when we know that that one from 6, 8, 10 is a right triangle. So this is 10 long. You couldn't see it from here. When you're looking at it, there's like, well, that's 1, and then here's like a partial, and we don't know exactly how long those things are, and we'd have to add them up. So this way, however, there's 1 and 1. It's right on the money. So let's go out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And put my pen down first, right where I want it to be drawn, and then draw. Man, that looks good. Put my pen down, put my mark, bring my straight edge up to draw my line. Super clean. So crispy. Right there. Wow. Alright, so this is 10, and this is C, and this squared. So really what we're talking about is, if a squared plus b squared equals c squared, I ought to be able to take these two and put them into that and they would be equal to that space. Equal to, excuse me. So I'm going to leave that there for now, and I'm going to cut these. This is where a slow-mo or a super fast video would be kind of cool. Kind of. Oh well. Not like I have this huge production budget. I mean, you do what you need to do when you need to do it, and you do what you have to do to get by. You just, right? That's what we're doing here now. Ensure that we all not just get by. We'd like to get by well, but and this is what I do to get by, to try to get by well. You share ideas with other people as well as I can. Maybe this is the second or third time I'm making this video. It's the first. Doesn't matter. Gotta do something as well as you can, no matter what you're doing. Yeah. Alright, so there's my triangle right there, my 6, 8, 10. Oh, it's beautiful too. You know, if you wonder if there's beauty in mathematics, right? It's right there. So, look at that, b squared. Bam! Now, a lot of people are like, well, how's this supposed to fit? This is stupid. I thought you said it was going to fit. Well, take this thing apart. Is not going to come down crashing around our ears if you decide to cut this thing apart and run it out there on the other side. I know a lot of people are freaking out right now because I'm cutting my square. So, but that's what you need to do if you're going to prove this thing. I'm going to put this thing right here. So I cut a rectangle that was too wide to see. Oh, great, now it's bent. Come here. Oh, yeah. Check it. So, another too wide to go on the other side. Yeah. Oh, sweet mammoth. So, right there. Nice. Dude, this looks like it's going to exactly the way that I wanted to. Just like, almost like it was a theorem that someone, or even me, had proven before and still going. So, I still need a 2 up there, but it's like 1, 2, 4 long. I'm gonna cut it 4 long. Ching. Oh my gosh. Look at that. Oh dear. Come here. I met a parrot in El Paso, Texas. And that's what it would say from across the room. Come here. And then once you got over there, it would ask you what your name was. And I told it Michael, and it kept like, Mike! And I was like, what in the world is he yelling at me for? And then I realized there was a little boy sitting out on the other side of the cage, and he was pulling the feathers on the bottom of the huge macaw. And every time the boy would pull on its tail, it was a very well-behaved bird. Man, look at that. Are you paying attention to this? Check that out. It's perfect. It's almost like a squared perfectly equal c squared. So if I grab this and pull it off of here, I can grab and pull it down and leave it where it is. Maybe. Go. Oh, that was crazy, man. Oh yeah, check it out. Nice. And look, it's 10 by 10. This is 10 by 10, and exactly what we're looking for. Dude, how can you get cooler than that? A squared plus b squared equals. That was when everything was like. So I didn't cheat, but I used something that I knew was going to work. So let's now use. Whoa, is this going to work? Because look at this. This is 1, 2, 3, 4, 5, 6 long, and it's a triangle, meaning that this side is equal to. It's an isosceles right triangle. and it's 1, 2, 3, 4, 5, 6, 7. Sweet. And that means that this is going to be 49 when it's squared, and this one's going to be 49 when it's squared. So if we have a squared plus b squared equals c squared, I almost wrote down 49, which is not true. So, and then a is 7, b is 7, squared is c squared, and then 7 squared is 49 plus 49 equals c squared. 49 plus 49 is 9 or 8. Yes, there was a 9er. Yes, we're on walkie-talkies. 98 equals c squared. Well, or if I'm going to find c, and find the square root of c squared, which is c, square root of 98. Now, the square root of 98 is not a perfect square. So, square root of 98 is not a perfect square. So what I'm going to use, I'm going to use my calculator. I'm going to put 9. I was like, oh no, where's my square root button? Well, you flip the phone a little bit. You just turn it. Okay, you'll rotate it, to use math speak. Rotate it 90 degrees counterclockwise, and it becomes a scientific calculator. So 98, and I'm going to hit square root. Whoa! How in the world write that entire number down? Oh, you know what? I don't think I'm going to be able to. Squiggly, squiggly. So c equal to this. Now, you know what? That looks like a number that's just not going to end. It's non-terminating. It also, that looks like, but there's no pattern in it. Some of it's close, but there's no pattern in it, which also means that it's a non-repeating, non-terminating decimal. Is irrational. This is an irrational number if I'm going to have difficulty finding exactly what that number is. However, if all I'm doing here is proving that this squared plus this squared equals this squared, I'm just going to keep rolling with it. Don't drop. So, this, oh my gosh, is approximately 9.899, okay, whatever. Let's go 8995, okay? 995. Now, if I square 9.8995, I'm not going to get 98. I'm going to get a little more than 98 because I rounded this up. So, we're cool. Let's stick with this. So, watch what happens when I square this side. 1, 2, 3, 4. 1, 2, 3, 4. 7. 1, 2, 3, 4. 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Put my pen down, straight edge to it. Pen down to it. Pen down. Straight edge to it. You've got a pen down. Excuse me. This is now 49, and this is now 49, because this is blue, a squared and b squared. And for a c squared. Now the issue again is I don't have a measuring device. This is what I'm going to do. I'm going to use the edge, the other edge that I cut for the when I need. Now this is going to be complicated. So just kind of what I'm going to do is I'm going to choose one of my edges to be 0. And I know this length an irrational number. Okay, it's an irrational length. So I'm not really going to be able to, it's not going to line up. Now it looks like it does, but it's so close, but it's not really there. It's really just right off of that line. It's just short of it. So what are we going to do? Well, what I'm going to do first is I know that this is going to go out that way, perpendicular. So I'm going to put my pen, it's going to be out on this line somewhere. So I'm going to put my pen here, and I'm going to line my straight edge up, and I'm going to go out. I don't know how far, so I go too far. Same thing here. I'm going to put my pen here, where I know it is, and I'm going to put my straight edge out. I don't know how far, so I'm just going to draw it. And you can see it just stayed the same distance away from that blue. How close it is. It's like 0.1 away, so from that thing. So make sure that I go the right distance out, because it's not on one of these lines, because those are whole numbers. So this is where we get it, not cheat, but that mark on that pen crease in the paper over, you can see the creases because you've marked into them. So what we're going to do here with this one is, since the pen's kind of creased it, we're just going to fold it around there, and the ink is just going to fold just perfectly where it was. Okay, so I'm going to fold that out. I'm going to put this. This is right on the corner. That's a corner right there. So if I can measure C across that, it will work for me. So I'm going to put this corner down here on this one, right where it is right there, and go back the other direction. See that it's right there to the blue line, but it's really, really close. So what I'm going to do here, use this distance of C. This is going to be my square. It will be C, 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 C long. So I'm using C along that line that I didn't know how long it needed to be, but I'm going to measure it like that. Okay? So if that doesn't make any sense to you, pause the video, go back, watch it again. So, and I'm going to put my mark on my line, and then I'm going to make sure that this one's going to be tough. Ruler is perpendicular there and parallel out. I'm going to draw my line. Ooh, check it out. All the way down there. There we go. So is C squared. That's not a pen that clicks. C squared. And 0.895 blah 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 blah. Reading, but just, it's irrational, so it goes on. However, this is actually an area of 98. Should be. Because that's what we have down here. So to prove that, I'm gonna cut it out. Wow, careful, man. Stop. Just gonna do this. I'm gonna cut right there. Oh yeah. Nice. Some stir action going on here. I don't know if you can. That sounds satisfying. Almost as satisfying as when I'm using my paper cutter. I'm about to make an origami sculpture, which I have done a couple of times now that I've completed a couple of them, and I started a third. The third one's a 1,000 frame project. It's for the wife. She doesn't know. Well, I guess she does know I'm doing it, but she doesn't know this that I'm going to leave it in. I'm sure she doesn't know what the structure is going to look like. I'm not going to tell you on this video either, because if someone says, "Hey, I saw your husband make a fool out of himself cutting stuff and talking about this," and then she goes and watches it, that's how she figured out I was working on the project in the first place. I won't tell you. I'm just going to look at that. Man, that's wow. Look how clean that triangle looks. So, for some, it doesn't work. So, here's what I'm going to do. I'm going to cut this and this are exactly the same. So,